As promised, last time around, pretty sure I mentioned, I'm sure I mentioned that I was gonna pull up this library, this linear assignment Rust library. This is not exactly a port, it kind of a long while ago. Maybe, let's see, how long ago? Let's see, Minecraft. There we go. 14 years ago. 14 years ago, I made this C++ implementation of the Munkres, the Kuhn Munkres linear assignment solver algorithm, and it's got some contributions since then. But this was in C++, and so a few years ago, I had decided that I was going to learn some Rust. There we go. Learn some Rust, and so that was 8 years ago. I guess I did something 4 years ago, but I don't really remember. It's been a while since I've done any Rust. But this was basically not a port, but a one of those things where I went through the original algorithm, what I was supposed to do, and I was like, let me imagine how I would implement this kind of in a more abstract way. Abstract's not the right word, but just like thinking through the problem and kind of what the algorithm is doing and trying to like really get inside of the algorithm instead of just simply transliterating the code, which is I feel like that's what I essentially did when I did the C++ version of this. Was I think I was looking at some Pascal code and other code. Hey Brainless, good morning. How's it going? So it took, whatever, looked at the pseudocode description of this algorithm in the past and just like re-implemented it in C++. And so with this one, this is more of a reimagining. I'm doing well. Last week I ended up taking, I skipped the stream on Monday and ended up taking Tuesday off of work just to kind of rest and try to deal with this cough and other things we don't need to talk about. But and I've mostly recovered from that. Throat is still a little, not scratchy, but definitely some. I probably sound a little different still a little congested, but better though, getting better and better each day. Not having to mute myself so much to cough. So there's a couple of things that I want to do this morning. One is remember how to code in Rust, I guess, and then also what this library does. And a third thing is I have this issue. So a very nice person on the internet opened this ticket back in April that I have been looking at and not doing anything about since then. And so 6 months later, I'm finally getting around to looking at this. And they have an example, like here's some code to run, which is pretty good, showing that this returns an incorrect solution apparently, and I'm taking their word for it. I've not run this yet, but I should probably where to start with this, right? So what does this code do? Might be a good place to start. So the linear assignment problem is this idea that you have there's a couple different ways of like representing what the problem is. You have like bipartite graphs and other things, but you could imagine you have let's see, what's a good kind of example? Let's say you have workers and jobs. And in this model, you have certain people are better at certain jobs than others. Maybe all jobs are doable by all people, or maybe some things are just not doable. You can represent that in this with this algorithm too. You can represent the problem to this algorithm in those cases as well. But let's say you have n people and you have m jobs, and maybe n and m are the same amount. So you have like 5 people and 5 jobs, or you might have 5 people and 6 jobs. And let's assume that you can find a numerical way to represent, I don't know, the cost of them doing the job, or maybe how good they are at doing the job, or something that would allow you to like pick one person for one job versus another. But what you want to do is essentially you want to imagine you're trying to like schedule a job shift, and you're trying to determine who goes into what position, like who's doing which job, so that you're trying to I think typically we're trying to minimize. Yeah, so like in this example, it returns 15. Well, that from the library is 16, right? So there is a more optimal solution, a less costly solution. So that's what this algorithm does. It finds a way to assign the people to the jobs such that the cost is minimized. And in this case, we're dealing with the square matrix. No, we're not. It is 3 by 4, right? So this is like, there's 3 people to do 4 jobs. How do you pick, how do you allocate those 3 people to do 3 of the 4 jobs such that the cost is minimized without one person doing 2 jobs, or 2 people doing 1 job, like that? It has to be 1-to-1. And I think that's where linear comes from in the name of the problem. So that's the problem that's being trying to solve by this code in a nutshell by this. And I do link to Wikipedia here, and I tried to do a different explanation here in this comments apparently. Which, if you know what a bipartite graph is, maybe this would be helpful. But I think the explanation I gave is a little bit friendlier, maybe, than this. And so what is this code? Okay, so we have something to do with a log. We have some types here. We have an edge. So U and V are essentially the dimensions of the matrix, right? U and V. So this is like, U would be like workers and V would be jobs. And so you could represent this as a matrix where each row represents a worker and each column represents a job, say, something like that. Although I'm not sure, the question of, we are passing around a matrix in this. I don't recall the ordering, which way it goes, but yeah, so we have an edge. We have a trait that is a weight. Now, what does this mean? I have no idea. It looks like we're combining different other traits together. Impl T 0 add output T sub output T ordinal copy debug wait for T. What does it mean? I don't know. And then we have a matrix size struct that we're using. Okay, and then I give an even more detailed explanation of what the code does here. Can we use neovim to work on the Rust code? Well, I have news for you. I already have neovim up. So we could actually just start looking at that right now. Yeah, so there we go. So different explanation here. Here we are interested in finding some subset of the edges E of our bipartite graph. Is the LSP working? Let's see. Well, cannot control click to look up a tag. How do we... K. Well, it's not space K. Yeah. I mean, lowercase k is definitely not it, but no, it doesn't appear that. Probably because I haven't done that. Is there a quick way? Let's see here. Did I install the things? You think I'm prepared? Didn't I have a .neovim folder in there? Got lots of things. Light table. Yeah, .config. I mean, you would think so, right? But hold on. Nope, that's not a thing. This is Windows. I'm not using the Docker setup. I felt like that was a bridge too far. Well, at least at some point I had Rust and Cargo and stuff set up here. I'm probably gonna have to update that. Let's see. App data. I am using lazyvim. Yeah, okay. Fair enough. We could do that. That's probably better than what I was trying to do. Neovim. Yeah, see it is. All right, and then that's something, but that's not all we need to do. What is the other place we need to add? Ah, here it is. Let's see here. So, lazyvim Rust. Bam. that didn't work. Nope. How do I paste? Some things. Yeah, I Control Shift V, you think? Nope. Well, I am in insert mode. Playing Rust. Yeah, a Windows thing. There's lots of those. I have been considering more and more having more Linux. Yeah, paste. Oh yeah. Yeah. It's like not that, like that. Is there a way? Is there a so? VSCode has this feature for like a screencast mode where it shows like the keys that I'm pressing. Do you know if anything like that exists? I had a typo in the version I typed anyway. Anything else we want to add here? Yeah, I feel like I searched for that before, but let's see, neovim screencast plugin. Show keystrokes. Keys.nvim plugin. Keys.nvim. I mean, at least they're honest. Alright, so how do we can we just do like import equals a thing? Is that how this works? Can we do that like that? Into plugins. What are we gonna call this? Keys. Then write. Hold on. Operation not permitted. Interesting. Right, because I'm in the wrong folder. Whoops, and oh hey, look. At least that did that. Let's see, update. Yeah, Q to exit this menu. Yep. Will this continue to run in the backend if I quit out? Maybe. Excellent. All right. Anyway, discovering all sorts of things. So anyway, Space open. Oh yeah, space E. Yes. Can we how do I create a file in this directory? Aha! Fancy. Okay, so what do I want to call this? Just keys.lua? Excellent. Question for help. Yeah. Alright, so let's just start from the beginning. So one thing I did do is I set up a thing where I can right click in a folder and I can launch neovim from the folder. It's kind of handy. Yeah, I don't have a C compiler. That is correct. Cool. All right, I need to do capital E here. All right, cool. So, ooh, Rust Analyzer. That's promising. Are you sure it's I mean, I recall it being capital K, but that doesn't seem to have done anything. LSP info. Detected file type Rust. One client attached. Okay. That's good. But this doesn't seem to have check health. Good one. All right. Languages. Cargo. Oh yeah, we should probably I should update Rust is what I should do. Okay, so because it's been like a long time. One thing you need to do is have Rust Analyzer install outside of nvim. Yeah. Let me just download the CXE and run it. All right. So. Messed up. Welcome to Rust. Yeah, that all looks fine. Yeah, that looks fine. That looks fine. Proceed. What could possibly go wrong? wonder what version of Rust did I have? One that was at least 4 years old. That's good. Then maybe what I can do next is is that the new version? That is the new version. We'll try cargo build next. Okay, cool. Ooh. Please ensure that Visual Studio... Oh, I might need to just restart terminal here. Alright. I could have sworn I answered yes. Build tools for Visual Studio were installed with Visual C++ option. Huh. When prompted to do so. Okay. Well. It needs that link tool in order to be able to link the library. And it doesn't actually need the whole, yeah, it doesn't need the whole Visual Studios, it just needs the build tools. So. Which is pretty funny because I was cleaning up my desks a month or two ago when I was reorganizing some stuff, getting these new NVMe disks installed. Oh boy, this thing. Okay. What is it that I need? Build tools. C++ CLI support for the 143 build tools. All right, let's can we go back? It'd be really cool if there was a link where it would just tell you exactly what to select. I mean, that looks like maybe it's the right thing. I guess we're gonna find out here shortly. What was I saying before? Yeah, so I had a couple of versions of Visual Studio actually installed that I removed. But that's fine. Probably would have had to update them anyway or do something else, so. Alright, so is this gonna work or am I gonna have to... Okay, let's try opening. Yeah. Another terminal. Build tools for Visual Studio. I mean, this is Visual Studio build tools. I guess I'm just going to click this. Now that's going to install some things I probably don't need, but hey, it's only like 2 gigabytes. I could have sworn the one option I selected before also said like 1.6 gigabytes. So anyway, I've been thinking more and more these days about switching over to doing more stuff on Linux. My daily driver laptop for work prior to when I was working at a startup, when it was like a bring your own device situation, was a Nix OS setup on a laptop. And Vim was my main editor at that point. And then between like gaming stuff and having a fancy gaming PC, and then work being at least started off as mandatory Windows, although that changed, I just kind of got into a, well, it's just all Windows situation. But yeah, I don't know. This desktop computer is pretty powerful. I could maybe just have a Linux VM that I worked out of if I was so inclined. Okay, we're installing more things. I really don't need a Windows 11 SDK, but I wonder if this is just going to start working at some point. Nope. Link.exe not found. Carbo. I like their note. VSCode is a different product, and it's not sufficient. These are many people are confused and ask many issues opened results in these sorts of notes. Okay. Well, while we're waiting, let's see. So, you have a Stack Overflow link for me. Yep. Yeah, restarted the machine after installation and compiling worked fine. Yeah. Yeah, you can change the tool chain. C++ build tools. Reboot. "25 years later, the answer is still reboot. I don't like it. Maybe what we need is in one of the remaining 100 and 180 packages, and this will work without the reboot. Yeah, I know, right? One, you probably already have build tools, you know, make and GCC and all that stuff already installed. And if you don't, you can just run a command and then it's there. And why would you need a reboot to be able to, you know, run an executable that would be installed into a folder that's already on the path? Yeah, I mean, it always says that it does. Sometimes it doesn't actually. Alright, so... that was the wrong command. The wrong thing to click. Carbo build. That looks promising. There. Alright, so the good news is this library that I haven't touched in 4 years does in fact compile. Is there a cargo test? Do all the tests still pass? Is this doing what I think it's doing? Alright, we're done with this. Let's see. So we have a dependency that is using code that will be rejected in a future version of Rust. There we go. Here's our tests. 11 passed. So what we need to do, going back to the problem at hand, right? So for this issue, I think the first thing I want to do is I want to make sure that this is true. And then I want to add a test case that fails. And that'll be kind of a first thing to do. And then we'll figure out why the algorithm is broken. And I don't know if that will be something I'll be able to solve. So I think it's true. Select 8, 4, and 3. 8, 4, and 3. Yeah, that looks right. Those are non-overlapping solutions. 8, 9, 10, 11, 12, 13, 14, 15. So that is the minimal value. And apparently the library returns 16. Yeah, that checks out. I mean, at least in this is a thing. Like, this is easier to check. You could I don't think there are, but there could be even lower solutions. But we know it's wrong if the library says 16, because it should at least be 15, because we can see that there's a solution of 15 here. So, I still have neovim up. Okay, there we go. All right, check health. Languages. Cargo. Okay. Looks good. Can we... There we go. All right, so that still doesn't work. You haven't seen scheduling problems since university? Yeah, I mean, it's been at least 4 years since I looked at this. But not this library, the Rust version, but the C++ version is my most popular repository in GitHub. I've definitely, like, I've seen, yeah, I don't know why the LSP doesn't work. Like, I've seen a lot of different, like, academic papers. LSP log, yeah, we can try that. So we're up to, I have 189 stars and 77 forks of the original C++ version of this thing. Anyway, that's not why we're here. LSP log? Doesn't like it. Nah. Some people, else, oh. Why isn't it the other way though? All right. Lots of things. What day is today? This is all old, right? This is October, right? There we go. All right. So, fetch work something something. Fetch workspace error. Let's analyze your failed workspace. Failed to load workspace. Failed to load the project. Failed to read cargo metadata. Failed to run cargo. Let's just try closing neovim and opening it again now that everything is fixed. Maybe. It doesn't like that I don't have a C compiler. Alright, and then we also want to open tests. Oh hey, that looks good. That's happening. Ooh, one implementation. Okay, so I think I just needed to restart it. There we go. This expression creates a reference. Beautiful. Lots of warnings. I mean, it's very possible that one, this was not the best code in the first place, and two, that things have changed in Rust in the intervening 4 to 8 years. Also, I left a bunch of to-dos. I think the idea is these to-dos are about like optimality, being optimal. Oh hey, hi Modprog and Raiders, welcome to the stream. I'm just going through some old Rust code and trying to figure out what I was thinking and how to code in Rust, among other things. How's everyone? Oh, cool emotes. Nice. I like your emotes. All right. I see how it is. All right. Well, enjoy your dinner. Thanks again for the raid. Look forward to seeing you some other time. Maybe you'll come back. All right. Oh, thank you for the follow. Getting ever so closer to that 50 for affiliate. All right. So code. What even? We got the LSP stuff set up, which is cool. Right, so I was gonna add a test because that I could do, maybe. So we have some existing tests that do things. Let's see here. Look, we even have one solve. Ooh, we can run the test inside of the editor. Nice. All right, so all right, I even have like a quick check test that unfortunately did not find the problem, but that's fine. Anyway, so it looks like we just do this macro. Solve issue. Yeah, exactly. That's exactly what I want to do. So this is issue 10. Okay. What? Let's see. It would be hilarious if Copilot had somehow like get the information from the issue. But no. All right. It's definitely wrong. All right. It's creepy enough already. Okay, so how are we representing this? So this is 3 rows, but it's 4 columns, right? And how is the data structured? Like, we're handing it like it's just an array, right? So is this... How is this ordered? So from row slice. Well, I clicked the thing and it brought me here. Interesting. From row slice. Creates a matrix with its elements filled with the components provided by a slice in row major order. What does row major order mean again? I should remember how to like do matrix things if I'm going to be working on this code. Could we actually just... Do we need to do this way? Like, could we just take this code? I mean, the question is... Oh, here we go. What if we just took this? And then... Oh, and we do... You see... I'm not sure if that showed all the key presses. You have to help me now. How do we indent? Ah, that works. Cool. This doesn't seem to be right though. Equal? Yeah. Rather than manually doing that. Yeah, that works. Very nice. So this doesn't appear to be valid syntax. Or I'm missing something to make that valid syntax. Rust array. Maybe it's from a crate, perhaps. I mean, it is more convenient than this, what I was doing here, where I was using the, what is NA? That's the in algebra, yeah. It is STD. Is there something I need to do to use it then? We all do. That's a macro, right? If it's an exclamation point? Years ago. Or maybe this is just an example. I don't know. My Rust knowledge is at least 4 years out of date. And 4 years rusty. Interesting. this. And then... No. Not at all. There you go. All right, and then, nope, because that copied the thing that I just had. Let's see. Da, 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 da. There we go. Oh, hello. Justice Flugel, maybe. How's it going? What am I missing here? Expected R parent. Oh, yeah. There we go. Okay, let result equal. Oh, right. So we need to have this be called test matrix if we want that to all line up. And then the cost should be equal to apparently 15. So if we save this, variable does not need to be mutable. Interesting. Okay. You should also do some programming, but you're not looking forward to what you have to do next, so you're procrastinating by watching some streams. That is relatable. I have been procrastinating working on this for about 6 months. But we were talking about we have been talking on previous coding streams about doing some Rust coding. Is this a control click? Nope. How do I do things? Like, it says run test debug. Which is interesting. It's the matrix crate. Oh, it doesn't work. Oh, that's too bad. You're using Helix? I don't know that I know what that is. Is that like a front end thing? A back end thing? How do I run this test? Code action. No code actions available. Okay, what about source action? Nope. Line diagnostics format, LSP info, Mason. Code action Rust. No code actions available. Okay. LSP info, that's just that, right? Okay, cool. Oh, Helix editor? Just, oh. Go to the terminal, run tests. What is this? It's the Dark Ages? Alright, well the good news, the test failed. It panicked. Slice did not contain the... Okay, so this was wrong. Let's see. So first of all, this is wrong, because this should be 4, right? 2, 3, 2, 3, 1, 2, okay, so that's wrong. And then, that's the first problem. Bacon is nice if you're using a terminal UI under. All right, so then, there we go. So now, this is the location in the matrix of the solution found, I believe. And then, here we go. So left 16, right 15. So left is the computed cost, and 15 is what we said it should be. So if if this is doing the right thing, then we reproduce the issue, which is terrible because now I have to figure out how this works. Destroy bacon. Why would you destroy bacon? All right, I'll also check out Helix. Oh, it's a postmodern text editor. Is that a oh, looks kind of familiar. Postmodern, it's a joke. If neovim is the modern Vim, then Helix is postmodern, I see. Here, that's what I'm looking at. It's a little too purple. Seems okay. I need to get used to what I'm doing right now. You used to now? Yeah. I figured. I was kind of just kidding about the purple. Way too happy with them. Yeah, I'm can't take too many things on at the same time. Okay, and what is this bacon thing? Very bright. There we go. All right. It's a background Rust code checker. It's designed for minimal interaction, so you just let it run alongside your editor to be notified of warnings, errors, or test failures. Yeah. So there's a thing that I use for TypeScript called Wallaby. Not exactly the same thing, but it allows you to see like test results in line. So like if you have unit tests, you can like edit the code and it on the fly runs the tests against your code and shows you like lines that are executed and that sort of thing. It looks like it's not exactly the same, but it reminds me of that. I really like Wallaby because it's pretty smart in terms of like running tests that are affected by the code in question. Yeah, and it's on window. You don't know why tests don't work in neovim for Rust. Yeah, I mean it looks like there's a thing that can be done here. Like it looks like you should be able to click it some way. Yeah. Okay. Well, that's some stalling. Why does this not work? So I guess the first thing to do would be to look at the solution that it's picking. And are we giving it the right data? So it's picking 0, 1, 2, 2, 1, 0. So in rows, 3 rows of 4 columns. Is that the right layout? 3 rows of 4 columns, yes. So it should be like this is how it should be laid out, right? And so if it's picking 0, is that row 0, column 1? Space dr. Okay, that also runs tests. Okay, I'll probably try that in a second so we can kind of step through the algorithm, which should be really fun. Let me try to make sure that I'm like visualizing what's going on here in terms of just the data though. So if this is row 0, column 1, so row 0, column 1 would be 5, and then 0, 1, 2, 0, 1, 2, 5, 7, and 4. So that would be 16. That's what it's picking. And the way this is working is it's taking those, the result is basically the coordinates that it's picking, right? And then it's iterating over that result. And for each entry, it is grabbing the cost from the matrix and accumulating it. Invent bacon. Okay, well, I am going to put those in some tabs, and I'll have to check that out. So, let's see, we can just save this, yeah, and then, so you said space DR. Debuggables. I can't tell. Are these just all the different? I can't tell what these are supposed to be. Is this? Invim DAP not found. Okay, cool. Maybe write the test name? Yeah, NVIM DAP not found is NVIM DAP. Debug adapter protocol. I guess lazyvim didn't give that for us. Lazyvim DAP. Oh, that's an extra. There we go. DAP core. Okay. So there we go. Neovim. Let me check if there's a test runner. Maybe it will come by default. I don't know. We'll see. Let me try this though. Config lazy. Let's see. So is there a way to reload config here? NeoTest also supports us having used it yourself though? Okay. Okay, well, we'll just gonna quit out, and then I have no patience to figure out how to do a thing when I can just close it all. All right, cool. You think it's colon E exclamation point? I believe that could be true. Maybe I'll remember that for next time. Okay, so space KR or space RK? I'm looking back through chat. Space DR. Issue 10. Compiling a debug build. I don't know. It felt like something was going to happen, and then nothing happened. Is it thinking, or it's not looking good? You kind of don't want to make your editor into an IDE anymore. Prefer working with multiple terminal windows. Yeah. If you wanted it all in one thing, you just use VSCode. You know, when I started using VSCode, which has been my main editor for a number of years now, I did have a Vim key binding, and there's definitely times when that's been helpful, or I've turned that back on when I wanted to do something. And there's definitely been times where I have spent a lot of time doing something that could have been faster with the macro, but not a huge number of times. I've not lost a huge amount of time on that sort of thing. I don't think this is gonna. You found one? Like a test runner thing. I mean, this seems like it should work. That runs the test in editor. I mean, that's. I was more interested in like the debugging, right? To like step through the code. In Vim test. Okay. Another link to the pile. Like, I bet that if we loaded this up in VSCode, I could really quickly get something where I could set breakpoints and do all that. Also, yeah. A breakpoint, that is a thing. Space DB, okay. Yeah, that's fair. Yeah, after I said breakpoint, I realized that that was the step I was missing. Okay, so we're going to let's just start here at the beginning. DB, huh? Hey, look, it's a breakpoint. Cool. Okay. Aha. Hey, look. Now this looks good. I mean, to be fair, other than like adding in like the Rust specific things, like all the rest of this stuff is kind of just like, and which is like, if I would have like set out to like be prepared for this in the beginning, I would have like looked at the lazyvim website, and I would have those things, and yeah. All right, so we are here on line 83, and this stops kind of looking like Vim at this point. I mean, you're also using yeah, exactly. This is lazyvim or lazy neovim or whatever it is. The last link. Oh yeah, for the nvim test. Okay. Alright, we'll have to check it out. But first, I want to figure out what's going on with this code. I would like to, make some progress. I usually, about halfway into the stream, take a little break. Just to, like, get water, especially on these Sunday streams where I'm only had coffee so far. And I don't know. We might, depending on how this goes, maybe I'll stick with the... I was thinking about switching over to working on some web dev stuff, but we could keep on working on this since we've only kind of scratched the surface. You have a croissant? Ooh, nice. Let's see. Using, if you by accident break something in nvim, you don't really understand what it's doing. That's totally fair because I don't. I just need to do key maps. Hey, having to write commands, that's fair. Yeah. No, I totally get that. I don't know. So I've used... This is the third editor / IDE setup that I've used on these coding streams because mostly I'm using VSCode. I've been learning how to do Minecraft mod development as well, and so I've been using IntelliJ after a brief foray trying to use neovim for that, using IntelliJ, and then neovim here, and that's probably enough. Maybe too much. Yeah, I used that for Minecraft Money as well. It's Java, although Kotlin, in the case of this stuff I've been doing, but still. Android Studio for Android stuff. Yeah, you use Kotlin? Nice. I have the experience I have with Kotlin is what I've streamed so far. So just a few hours, but it doesn't seem bad. It's just a little different. So can we just step over? Can I click this? Yes. Great. And we have locals here. I can click and drag this too. That's nice. It's really nice. Trying to write your own Minecraft server in Rust? Ooh. That is, that'd be interesting. I think that's something. That would be a fun project. I don't know what the network protocol for Minecraft client and server looks like. So hopefully it's not too bad, or hopefully there's a way to kind of do it progressively. It's well-ish documented. Well, there's that at least. So what can we see here? So we have a matrix and a matrix size, and so we can see that here in our locals. Can we? Okay, so we can see the contents of it here. Can we? Good. We can hide the Explorer. Give ourselves a little bit more space. Yeah. And the Minecraft EULA doesn't permit modding. Well, that's very good considering the number of hours I've spent playing modded Minecraft. Alright, so we have a size, we have a matrix, we have columns and rows covered. How long have I been using Rust? So, in terms of hours spent coding Rust, not a lot. This library, apparently I started working on 8 years ago. Hover a variable and space to E. Okay. Where is something that we would actually have stuff inside of right now? I guess just size, right? Ooh. And we can double click that to expand it. And then that goes away. Cool. So we don't have to futz over here if we don't want to. Okay. Alright. Cool. Yeah. So I don't have a lot of experience with. I wrote this library, which I thought mostly worked, although now we have a test case that shows in one case it doesn't work. Yeah, tracing. It's from the log crate, I think. Again, this stream is a couple of things. One is getting Rust working again locally. It's me futzing around with neovim. It's me remembering how anything works in Rust after not touching this library in 4 years, and then also trying to relearn this algorithm, which I've implemented twice. Once in C++ and then again in Rust, and apparently I did not do as good of a job the second time as the first. Something honking outside. Yeah, so okay, so what is this doing here? So we have some min size stuff. So what was it? DE? So 3. So one thing we do know is that if we have it's not tracing. Yeah, I mean, it depends on what you mean by tracing. I prefer tracing, to be honest. Yeah. I mean, at the end of the day, this should be dumping this in the console. Oh, you have a link. I will open link. A scope structured logging and diagnostic system. Is this, oh, it's a crate. It's not a built-in thing, right? Oh, so this does, like, you can do spans? Oh, nice. Yeah, that would be good. So actual, like, application tracing. What's the worst that could happen? You know, up until, like, a month ago, you couldn't even put links in chat. I had that turned off. Look, I'm going to open links. I'm going to download EXEs and run them. This is this is how I live my life now. Anyway, what are we doing? Okay, so there's kind of two modes with this algorithm, right? So you can have like a rectangular matrix, or you can have a square matrix or a rectangular matrix. I think you'll switch to this because of maybe so. Yeah, so the problem with I have autoplay disabled, so there's that. But I'll have you know that Rick Astley's song is actually I really like that song. As a matter of fact, I don't know why more people don't. I'll never give it up. Anyway, so if you have a square matrix, then for every, going back to the worker job analogy and like scheduling, then it all pairs up evenly. But if you have a rectangular matrix, you either have insufficient workers to do all the jobs, or you have insufficient jobs for all the workers, and so some will get excluded out. But that's still allowed by the algorithm. It's just not going to give you it's going to give you the minimal number, right? So taking the minimum of columns and rows, the number of results will be that min size. Now, actually looking at this check could be simpler, because we could just check to see if min size is 0, actually. So if it's an empty, if it's a 0 dimension matrix, a 0 width or length, whatever. If it has no columns or it has no rows, we could just return an empty set. And then we reduce edges. So past me said, for setup, we need to change matrix so that every column and every row has at least 1 0. So if you find a minimal value in each row or each column, basically there's a way to transform all the values so that you can have at least 1 0 value in each row and column. Because we're not interested in actually calculating the minimal value here. We're just trying to find the edges that will minimize the assignment. We don't need to keep the weights. What does the algorithm even intend to do? Well, there's a few different explanations for that. But the short version is, if you imagine that you have a job roster or schedule, right, where you have N employees and you have M positions or jobs or tasks to do, and those employees are either, there's a differing cost depending on which job each employee is assigned, whatever that means. Maybe this is like their happiness in doing the thing, or maybe they're going to well, let's just go with happiness. And this would be inverted because we're trying to minimize the value. So we're trying to match up workers to jobs in a way that minimizes the cost across the things. Yeah, to drive there in hours. Yeah, that's fair. Yeah, if you had a bunch of different jobs that were differing distances,
and you wanted to pick the set of workers. Like you can only send, there's a job and you can only send one person, and one person can only do one job. That's the key thing to this. It's a one-to-one mapping between these different kinds of nodes, right? So, and you're trying to minimize, you're trying to essentially schedule. You're trying to pick who you're going to send to which place, right? To minimize the total number of hours driven, right? And so you're trying to pick, like if you have, you know, Bill going here and Mary going there, such that their overall number of hours driven is minimized. So you could imagine you have, you know, more places to go than people to send, and so some place just won't get picked. Now it would be weird actually to well, I don't know. Anyway, point is that yeah, you're trying to minimize this cost, but by matching up pairs of things. And this algorithm can do that optimally. And like, is it like cubic time? What was the repo? So this one is called Linear Assignment Rust. Here, I'll put the link in chat. There you go. There's some other things I need to attend to as well, including probably switching to GitHub Actions, and looks like there's a security issue that's being complained about and some other stuff, but I figure that the algorithm not working 100% of the time is kind of a kind of a problem. Yeah. Okay, so what does reduce edges do? Can we step into this? There we go. Right, so so it looks like what we do is we find the smallest value. What does this do? Find smallest vector. Matrix, size rows, size columns, row column, row column. Interesting. Okay, smallest in a row is a vector of values. So this is saying like across all the rows, what is the smallest value in each row? Yeah, for parallelization. Probably. I think so. And that is definitely a reason you might want to use Rust to do this in terms of you know, managing mutability of values when you're trying to, you know, do this concurrently, this processing. The way the algorithm works is a lot of like data munging and tracking different information about the overall structure of the matrix. So the first thing we're doing here is we are, okay, so here's like find smallest in vector. So this builds a vector. So we take outer size, inner size. So we're like, take the first as initial smallest value, then we'll search the remaining to find the smallest value for each. Right. So we're building this vector of values, and we're initializing this entry, and then we are scanning to see if there's a smaller value, and then we're updating that. And so we're building a vector of things, of smallest values in a particular direction. All right, where were we? Do I have a call stack here somewhere? Here's the breakpoint. It also seems to me like you could pretty easily turn into a graph problem. I mean, in a way, it is. In fact, one of the ways the problem is described here is that it's helpful to think of the data as a bipartite graph, with weighted undirected edges, fully connected, all elements of set U to all elements of set V. So that is a way of formalizing like what the algorithm is trying to solve. All right, so reduce edges. What is the goal of this create? How does it differ from other creates? Well, that is a question. I think, first of all, I don't know at the time when I originally created this was like 8 years ago, that there were any others. But the intent was essentially to, for me personally, was I'd already implemented this in C++ and I wanted to learn Rust. And so I wanted to implement this algorithm in Rust, but also kind of at the time learn, like really get a like an internalized understanding of what the algorithm did versus just re-implementing it by rote, just like transliterating the elements of the algorithm where it's like, oh, here's step 0, here's step 1, here's step 2, here's step 3. Which you see like when I implemented the version in C++, that's like every implementation was just that re-implementation of like, oh, it does this step and then it does this step, and it's that kind of just like by rote structure. Other creates where you ask, do you really need that? SemD NBT. Minecraft NBT parser used to. I mean, maybe someone wants to parse a lot of NBTs. I don't know. You'd be surprised. I mean, there's definitely a you're not gonna need it sometimes effect where you think, oh, I'm gonna have this problem, and you kind of like in your head build up something that you think you're going to need, and then you go down a rabbit hole. Gigabytes of MBT? Terabytes? Exabytes? I don't know. Anyway, so can we... There we go. # takes us to the definition there. All right, so we find the smallest value in each row, and then we scan column-wise as well. But before we do that, we mutate the matrix. So I think we build a vector of the smallest value in each row, and then, well, that's kind of interesting because effectively what this is doing, there we go, for row and rows, column and columns. Okay. I'm not sure. Like, we're not doing anything with smallest in row, right? Why? I mean, I think theoretically we could have just mutated in place when we were scanning, because we don't, it's not like we're mixing the values from different rows together. I don't know. I mean, I guess this is fine to do like this. It at least makes it clearer what's going on, maybe. An assertion that we don't actually make, just a comment here, that now every row will have at least 1 0. And by 0, I mean there will be a value of 0 in every row in this modified matrix. And that should not affect the overall relative weights of the edges. Like, none of this should affect the overall relative weights of the edges. So that's that. And then this introduces the idea of stars, where we'll initially have the algorithm proceeds by starring 0 weight edges that are optimal with respect to the graph containing only edges that we have starred. What does that mean? Proceeds by starring zero-weight edges that are optimal with respect to the graph containing only edges that we have starred. So if we can, so that feels like a subdivision thing, right? So we're subdividing the problem into subsets of edges that we determine are optimal, and then we can kind of grow that. Why not use iterators for smallest in row and so on? That is a question. That probably would be better. Yeah. Well, I'm sure it is. So this is written by someone who had never written any Rust before. And I will say, I wasn't setting out to, my recollection of me from 8 years ago, I was not setting out necessarily to make something more complicated, but definitely to kind of think through the structure of things. But I agree that given the fact that we only consume the smallest row once, like we figure this out, maybe an iterator would make sense. I don't know. Worth considering. I think the main thing right now has to be this library has a flaw. I mean, besides, structural, oh, this is not optimal, or this is not structured well, or what have you, any kind of structural changes, unless it's going to be something that's going to get us towards correctness. Also, you're always passing around T and matrix size. Yeah, so this T is because I think this is generic for the matrix type. And then the matrix size, yeah, use struct to hold the matrix, like some kind of wrapper around it. That's fair. Probably so. I would have to think about, like I would need to, yep, so, yeah, that makes sense, definitely. I mean, this was essentially a port of a C++ library, or a reimagination of one. So I think that is an accurate summary. All right, so let's get back to, can we just step over? Okay, so some stuff happens, and we have a matrix. What was it? Space. There we go. What's fun though is that it looks like this matrix type that we're passing around has the size in it already. And in Rust, for example, you don't need always the beginning and end of iterators, I think you mean, like you tend to do in C++. I'm not exactly sure what you mean by that. But here we can see we transformed our original set of values. Now, so we have 1, 0, 2, 0, 0, 0, 0, 0, 0, 2, 0, 3. So that's the matrix that we've gotten out of the original matrix. Three rows, 4 columns. Okay, that looks right. So the original one was 8, 5, 9, 9, 4, 2, 6, 4, 7, 3, 7, 8. Now, This doesn't seem right. For example, with std accumulate in C++. Oh, you have to pass, yeah, the beginning and the end. Yeah. It's been even longer since I've done any C++. So just putting that out there. But yeah, that looks familiar. Yeah, these days I mostly do TypeScript. All right, so I'm gonna stew on this for a little bit. Maybe there's like I don't know, but I need to get some water and stretch my legs for a little bit because I've been sitting here for an hour and a half. Oh no, JavaScript's kind of broken. Yeah, it's its own special thing. Every language has problems. Maybe JavaScript has more, but it's the pain I'm used to. Anyway, I'll be back in just a couple minutes. I think we're just gonna keep on working on some more Rust performance stuff in JS. All right, be back in just a few, and we'll do some more Rust.